Opening the box for the FPV250, you should find a one-piece glass fiber body with detachable landing struts, 4 Multistar 1704 motors, a set of 5x3x3 propellers, 4 Afro version 3 12-amp electronic speed controllers, a power distribution harness, a 1000 mAh Turnigy LiPo battery, servo leads, and the hardware for an FPV mount. This tutorial will show you how to integrate the airframe, leaving the FPV for another video. To complete the build, you'll need a 4-to-6-channel radio, a flight controller, and a battery charger. On the tool side, you'll want a small Phillips screwdriver, a set of Allen wrenches to tighten the hex bolts, a tube of Loctite glue, zip ties, and some snips. The first step is to run the included Velcro strap through the slots at the bottom of the cage at the center of the frame. The strap will hold batteries, wires, and other equipment that you may want to strap to the bottom of your quad. Next up is the flight controller. We chose the KK 2.1.5 for its simplicity and ease of setup. It, or your flight controller of choice, goes into the cage to protect it and keep it at the center of the combined thrust of the motors. When installing the board, make a note as to which way you want to be the front of your quad. With this frame, any way could be the front, but if you plan to use the FPV mount, the forward is the shelf with a cutout for the FPV hardware. This is important, because flight controllers need to be pointed in the right direction to control the craft. All controllers will have some way to tell which way should be pointed forward. On the KK, the buttons are always towards the rear of the quad. 4 screws secure the controller and a roll cage gives it a measure of protection in the event of a crash. The landing struts are friction held onto the end of each arm so that you can put them on and take them off during construction as needed to gauge clearance. Once you're done with integration, a little dab of CA can keep them from vibrating free or popping out after hard landings. The kit includes 4 Multistar 1740 1900 kV outrunning motors that mount directly onto the frame with the included M2 6mm bolts and washers. It's very important, if you ever need to replace these bolts, that you not use bolts longer than 6mm. Longer bolts risk penetrating too far into the can and making contact with the windings, destroying the motor. Before you install the bolts, dab some Loctite glue on the threads. You need only a very thin film towards the bottom of the bolt. The Loctite will help keep the bolts from vibrating out of the mounts while allowing you to remove them when needed. Do not, I repeat, do not use Loctite red, as that will effectively fuse the bolt to the motor. With the motors mounted, it's time to get wired up. The frame uses a honeycomb lattice, and I prefer to keep my wiring neat by dropping the motor's bullet connectors through the lattice so I can keep the top clear for the ESCs. All of the following instructions will assume that you're looking at a KK board with the buttons towards the bottom. You'll see 2 rows of 3-pin headers to the left and right of the board. The radio receiver leads will connect to the left side, while the ESCs will connect to the right. The kit includes 3 servo leads, which will allow you to connect 5 channels between the receiver and the KK flight controller. I know that sounds strange, but you only need the full 3 pins connected for the first channel. 1 pin provides the signal for channel 1, while the other 2 pins will feed power from the controller to the receiver. Taking a look at the receiver, you'll find a schematic for which pins are signal and which are power. Find the lead with all 3 wires and block connectors and plug one end into the receiver's pins for channel 1, making sure to use the white or yellow wire for signal. Then take the other side of the lead and plug it into the topmost set of pins on the left side of the controller, with the white or yellow signal cable towards the inside of the KK. To connect the other channels, take another lead and connect it to the signal pins of channels 2 through 4 on the receiver. Note the color of the wire connected to channel 2. Now connect the other end of that lead to the KK, remembering what color channel 2's wire is and making sure to connect only to the signal pins towards the inside of the board. Use the last lead to connect channel 5 from the receiver to the controller. Now that you've connected the receiver, let's connect the KK's alarm. You should have received a small 2-wire buzzer with your KK. On the top side of the KK, you'll see 2 pins labeled buzzer. Connect the buzzer, making sure to connect the red to the positive pin and the black to the negative. The ESCs will be connected to the row of pins to the right of the KK, with the topmost set of pins for ESC1, the second set for ESC2, and so forth. Looking at the frame, the number of the ESC, and thus the motor, is as follows. The front left arm is number 1, front right, number 2, bottom right, number 3, bottom left, number 4. Make sure that the ground wire is to the outside of the board, the positive wire is in the middle, and the signal cable, usually yellow or white, is to the inside. Special note: Be careful with how you connect your ESC leads. The ESCs include a battery eliminator circuit, or BEC, that provides power to the flight controller and the receiver from the main battery, but they can fry electronics if incorrectly connected. Check and double-check your connections before you apply power. Another note, the KK 2.1.5 can accept all 4 ESCs, each with their own BEC, and only take power from channel 1. However, some flight controllers will fry if you connect them to more than one BEC-equipped ESC. If you're using such a flight controller, snip the red center wire on ESCs other than the first, or just pop it out of the plug and wrap it to keep it from making contact with anything else. Thread the leads from the ESC down through the frame so that they can be connected to the motor leads. Connect each motor to its corresponding speed controller, remembering the numbering. There are 3 leads from each motor and 3 bullet plugs on the end of each speed controller. It doesn't matter what order you plug them in, just make sure that each motor is connected to only one speed controller. With the ESCs connected, we can now power up the craft and check motor rotation. The kit includes a power distribution harness. Connect the 4 red wires from the ESCs to the red block and the 4 black wires from the ESCs to the black block. Take a moment to look over your connections to make sure that everything is plugged in correctly. Take your time. If any connections are incorrect, the next step could smoke your electronics. Once you're satisfied that you're wired correctly, turn on your transmitter and connect the power plug to your receiver. After a few beeps, you should see the flight controller and receiver power up. The first thing we need to do is to make sure that the flight controller is receiving input from your radio. Hit the rightmost key on the KK to enter the menu, then scroll to Receiver Tests and hit the rightmost key again. You'll see values from inputs from your receiver. Move your sticks to make sure that they're controlling the right channel. If you're in Mode 2 on your transmitter, moving the right stick up and down should change the elevator values, while left and right should change aileron. Moving the left stick up and down should change throttle, while left and right should change rudder. Now let's check rotation of your motors. It can be difficult to see which way the motors are spinning, so I put a piece of tape on the shafts to help me see their rotation. With the KK screen in safe mode, pull the throttle all the way back and to the right. The KK should now arm. Now gently cycle the throttle to get the motors spinning and watch the tape as they spin down. Motors 1 and 3 should be spinning clockwise, motors 2 and 4 counterclockwise. Make a note of any motors that have to be reversed, then disconnect the battery. If you have any motors that need reversing, simply swap out any 2 of the 3 motor connectors for that motor and ESC. It doesn't matter which color, just remember to swap the motor connectors and not the controller or power leads. Power it up and try the test again. When you're satisfied that they're turning the right way, the last electrical step is to calibrate the ESCs so that they all have the same values for start and stop. With the quad's battery disconnected, turn on your transmitter and advance the throttle to full. Hold down buttons 1 and 4 on the KK and keep holding them. Connect the quad's batteries. The controller will go into throttle pass-through mode, and you should hear a beep that will verify that all 4 ESCs have calibrated 100% throttle. Continuing to hold the KK buttons, move the throttle to 0%. You will hear another set of beeps to confirm calibration of 0% throttle. Release the KK buttons and disconnect the battery. Use zip ties to lock down the ESCs, cables, and receiver. Screw the cage top onto the frame and tidy up your wiring so that no connections are overstressed. With everything tidy, install the propellers on each motor, remembering that you want clockwise props on motors 1 and 3 and counterclockwise on 2 and 4. Use the washers and nuts to lock the props, and your system integration is now complete.